Alright, in this video we're going to be finding the orthocenter using coordinates. So first thing I'm going to do is just draw a quick sketch of the triangle that I'm working with here. So A is going to have coordinates -2, 3, B is going to have coordinates 2, 2, and C is going to have coordinates 2, 7. So those are my coordinates of my triangle, and I want to find the orthocenter. Now remember, the orthocenter is going to go from one vertex to the opposite side, and it's going to be perpendicular to the opposite side. So my first one, I'm going to draw from C, and it's going to go and it's going to be perpendicular to that side. Now remember, the orthocenter does not necessarily go through the midpoint, and we'll clearly be able to see that from the one that we draw from B here is going to go like that, and it's going to be perpendicular to side AC. So once again, I'm looking for the equation for two lines, just like I am on all of these. So I'm going to start out with y minus y1 is equal to m times x minus x1, and y minus y1 is equal to m times x minus x1. Alright, in both of these, again, if I use this one going from B, I can put in 2 and 2 for my point. So y minus 2 is equal to m times x minus 2. And likewise for this one, I know that I'm going through C, so excuse me, y minus 7 is equal to m times x minus 2. Now on both of these, all I need to do is find the slope. Well, to find the slope, again, the only way I can do this is that for the one going through B, I know that I'm perpendicular to side AC. So if I find this if I find the slope of side AC first, then I'll be able to find this one, slope of this one, because it'll be the opposite reciprocal. So since this AC goes through 2, 7 and -2, 3, I can find the slope by saying 7 minus 3 all over 2 minus -2, which is change in y over change in x. And I get a slope of 4 over 4, which is equal to 1. Therefore, side AC has a slope of 1. Therefore, this, which is perpendicular to AC, has a slope of -1, which is the opposite reciprocal of that. So I know the slope of this line, y minus 2 is equal to -1 times x minus 2. Alright, now I have to find the slope of this line, and on my paper it looks vertical, but it is not, or maybe it is, and I just need to verify that it is, or something like that. But again, to find the slope of this line, I know that it's perpendicular to this one, so I find the slope of this segment going through A and B, and then do the opposite reciprocal. So the slope would be 3 minus 2 y's, change in y's, over change in x's, so -2 minus 2. So that gives me a slope of 1 over -4. So that's a slope of -1/4. So therefore, the slope of the line that is perpendicular to that, so this one has a slope of -1/4. The slope of the line that's perpendicular, this one right here, the altitude, is going to have a slope of 4, because that would be the opposite reciprocal. So we plug that slope in. Y minus 7 is equal to 4 times x minus 2. Alright, now I can solve both of these equations for y. So y minus 7 is equal to 4x minus 8. Add 7 to both sides, and I have y is equal to 4x minus 1. On this one, y minus 2 is equal to -1x plus 2. Add 2 to both sides, so y is equal to -1x plus 4. Now I can just, since again I'm looking for that point where the altitudes cross, I know the x and y's are the same there. So this y is equal to that y, so I can set those two equations equal to one another. So 4x minus 1 is equal to -1x plus 4. Add 1x to both sides, add 1 to both sides, so I have 5x is equal to 5. Therefore, x is equal to 1. Now from there, I can take this x equals 1, plug it into either of those equations, and I should get the y value associated with that x value of x equals 1. So I plug it into this one, so y is equal to 4 times 1 minus 1. So y is equal to 4 minus 1, y is equal to 3. So the coordinates of the orthocenter would be 1, 3.